Good morning! We are now in week number 7 of our grade 8 mathematics lesson with the topic Systems of Linear Equation in Two Variables. As a recall, linear equation is an equation of the first degree. To represent this equation, we may write it in standard form, which is ax plus by equals c, or in slope-intercept form, which is y equals mx plus b. When we say system of linear equation, we mean it is an equation with two or more linear equations with the same variables being graphed in one coordinate plane. To begin with the lesson, we aim the following objectives. Number 1, illustrate systems of linear equations in two variables. Number 2, graph a system of linear equations in two variables. And number 3, categorize when a given system of linear equations in two variables has graphs that are parallel, intersecting, and coinciding. For learning task number 1, we have here 3 pairs of linear equations. All we need to do is to graph each of these pairs in one coordinate plane. Number 1, y equals 2x plus 2 and 2y equals 4x plus 4. Number 2, y equals x minus 5 and y equals negative x plus 3. And number 3, y equals 2x minus 3 and y equals 2x plus 4. In number 1, the second pair 2y equals 4x plus 4 is equivalent to the first pair y equals 2x plus 2. In numbers 2 and 3, they are both written in slope-intercept form. So the following are the graphs of the 3 pairs of linear equations. In number 1, the graphs of the first pair are coinciding lines. In number 2, the graphs are intersecting lines, and in number 3, we have parallel lines. All of these equations are being graphed using the slope and y-intercept. The y-intercept is plotted first, then the slope is applied. So, to emphasize, the graph of systems of linear equations may coincide, may be parallel, or intersecting. Example number 1. Graph the system using slope and y-intercept. Letter A, y equals 2x minus 3 and y equals 2x plus 1. In y equals 2x minus 3, the y-intercept is negative 3. So we plot 0, negative 3 since the y-intercept is the value of y when x is 0. And then from point 0, negative 3, we move 2 units up because the slope is positive 2. So the graph of y equals 2x minus 3 is shown using the red line. On the other hand, the graph of y equals 2x plus 1 is shown using the black line. Take note that the slopes of the two equations are equal. Those are the coefficients of x. But their y-intercepts or the constants, which are negative 3 and 1, are different. Therefore, the graph of the given pair of linear equations are parallel lines. When we say parallel lines, these are lines that never meet, however, they are extended. Example number 2. The pair y equals negative x plus 3 and y equals 2x minus 3. The graph of the first equation is shown using the yellow line because the y-intercept is positive 3. So it lies in the positive y-axis. While the graph of the second equation is shown using the pink line since the y-intercept is negative 3, so it lies in the negative y-axis. Take note that both the slope and y-intercept of the pair are different. Therefore, the graphs of the pair of equations are intersecting lines, lines that meet at exactly one point. Example number 3. We have the pair y equals x plus 1 and 2y equals 2x plus 2. When graphed, the lines are coinciding lines because the two equations are equivalent. When we rewrite the second equation 2y equals 2x plus 2 in slope-intercept form, we get y equals x plus 1, which is exactly the first equation. And take note that the pair have the same slope and same y-intercept. So the graphs are coinciding lines, lines that lie exactly on top of each other. So, to summarize, in example number 1, the graphs are parallel lines. They have the same slope but different y-intercept. For example number 2, the graphs are intersecting lines. They have different slope and different y-intercept. For example number 3, the graphs are coinciding lines. They have the same slope and same y-intercept. So now, kindly answer learning task number 2 for practice in your math notebook. So, without graphing, tell whether the graphs of the system of equations are parallel, intersecting, or coinciding. So, just compare their slopes and y-intercepts. So, that's all, and thank you for listening, and I hope you learned from this lesson.